host 2. Recommended study time 180 minutes. Module 10 required reference International Mechanical Code 2021 Chapter 5 and International Fuel Gas Code 2021 Chapter 5. Illustration 10A Protection through exhaust. Remember that the code regulations surrounding the handling of exhaust are there to protect occupants and the structure itself from air contaminants and fire. Study tip: this module covers specific exhaust systems that may not be in every building or every common. There are a lot of individual requirements to each of these systems. Try to pay attention to the pattern and the overall goals of the code, including where to look up the specifics. Don't try to memorize or even get too caught up in the detail of this system. Closes dryer exhaust. International Mechanical Code 2021 Chapter 5 Section 504. International Fuel Gas Code 2021 Chapter 6 Section 614. Throughout this module, we will cover a number of different topics, starting with closes dryer exhaust, which have specific regulations. Illustration 10b Closes fibers. Closes dryer exhaust system carry closes fibers in hot humid air and in gas dryer, product of combustion. When the fibers collect in length, they are usually flammable. The goal of the system: the ducts must run to the outside of the building because fire dampers are not allowed. The exhaust duct cannot go through a fire-resistant assembly. Vertical risers required clean out. Another way of cleaning the interior. Defining terms: a backdraft damper is required where the duct terminates, but screens are not allowed. This damper prevents expelled material from moving backward against the direction of the system. Screens are not allowed in order to eliminate the accumulation of lint in the duct. Some do's and don'ts. Understanding the code. Makeup air is required for dryer exhaust systems that are bigger than 200 CFM. Closet locations, a closet location requirements. This illustration 10C. A closet dryer located in a closet required an opening into the enclosure of at least 100 square inches. Residential clothes dryers, residential and commercial clothes dryer have distinctive regulation regarding their exhaust. Study tip: residential exhaust duct construction requirements. Smooth interior finish with no deformation to fit in installed location. A 4-inch diameter constructed of metal at least 0.016 inch thickness, support at 4-foot interval and secured in place. The insert ends installation in the direction of the airflow. No object allowed to protrude more than 1/8 inch into the inside of the duct. Illustration 10D. Transition ducts. Transition ducts must be limited to 8 feet and cannot be concealed. Transition duct connect the dryer to exhaust system duct. Understanding the field. The code solicits that the manufacturer instruction must be followed. The manufacturer should not deviate for the code but will include specific instructions necessary for installation specific and optimal operation. Duct length. Illustration 10E. Power ventilation. If a power ventilator is used, the maximum length of exhaust duct is now determined by manufacturer installation instruction. Where the equivalent length exceeds 35 feet, the length should be identified on a permanent label or tag within 6 feet of exhaust duct connection. Study tip: remember that equivalent length accounts for elbow, tees, and other fittings in the ducting. There are charts to look up the equivalent length of those fittings to add the actual length of the straight runs in order to get to the total equivalent length. This was discussed back in Module 4 under sizing the longest length method section. Commercial clothes dryers. Let's look at commercial clothes dryers requirements in the code. The commercial requirements are more stringent than residential, which is normally the case with building code. Illustration 10F. Fan motor and the airstream. Exhaust fan motor are to be located outside of the airstream. This is to prevent lint from collecting in the motor and fan assembly and becoming a fire hazard. Image provided by Tijerno Land. Here, fan motor and the airstream. One fan serving multiple dryers. Fast facts. Ducts have a minimum clearance requirements of 6 inches to combustible multi-story dryer exhaust system. There are additional requirements for multi-story systems for exhausting closest dryers, but they match the intent of the dryer exhaust code that we have already reviewed. Let's look at those code requirements together. Note that makeup air is required here for the exhaust system construction. Shaft in which a duct is installed must be constructed and fire resistant rated as required by the International Plumbing Code. Also rigid metal ductwork of sheet steel with a minimum thickness of 0.0187 inches. Number 26 gauge is required. Additional construction requirements for multi-story exhaust structure. Illustration 10G, the shaft clean out. A clean out opening is required at the base of the shaft. The finished opening must be at least 12 by 12 inches. Any penetration passing through the shaft and ductwork must be protected per International Mechanical Code 607.5.5.5 found in exception 2 study tip. This section 607.5.5 in the International Mechanical Code about exhaust refer to specific exception in chapter 6 about ductwork that talks about some exhaust system. This is the type of thing that the International Commercial Code loves to write test question about. A question seems to be about exhaust or any other subject for the matter, but the answer is found in another, less obvious section. Remember, it's not about memorizing these types of reference, but knowing how to use the code book to follow the reference to the other section. Motors and fan for flammable vapor or dust. International Mechanical Code 2021 Section 503. Vapor and dust can be flammable. Think about mechanical and exhaust system used in hazardous storage area or manufacturing and processing facilities involving high risk to health or fire. This would be classified as high hazard group H in our international building code to mitigate the additional risk created with flammable vapor and dust. The fans and motors used in the exhaust system have some special requirements. Think about it. There is needs to be a manually operated remote control to shut off fans or blowers. In the case of the emergency or if a situation warranted it, this also correlates with the requirements that the equipment and appliances that generate the vapors or dust must be interlocked with the ventilation system. The ventilation system must be on for the equipment to be on, motor and fan. Illustration 10H radial plates and tube axial fan. The system handling materials that can clog the plates required a radial plate or tube axial fan. Understanding the code, the exhaust equipment need an identification plate starting the design ventilation rate. Hazardous exhaust system, International Mechanical Code 510. As we already introduced, hazard exhaust system are systems designed to capture and control hazardous emissions generated from product handling or process and convey that emissions to the outdoor. Hazardous emissions, flammable vapor, gases, fumes, mist, dust, volatile or air-prone material posing a health hazard such as toxic or corrosive material. Fast facts: the health hazard rating of material are specified in NFPA 704. When is a hazardous exhaust system required? A hazardous exhaust system is required when any of the following conditions would exist if there were no exhaust system under normal operating conditions. 1. Flammable present concentrations above 25% of the lower flammability limit. An air-prone health hazard rating of 4 is present in any concentration. 3. Airborne chemicals with a health hazard rating of 1, 2, or 3 are present in concentrations above 1% of the medium lethal concentration by inhalation. Illustration 101 Laboratories. Laboratories can have incompatible materials as defined by the International Fire Code as long as a list of provision is followed. including have flow regulating devices, filters and cabinets, and certain hot and redundant fans. Design of hazards exhaust system IMC 2021 section 510.6 system used for exhausting particles must be designed to maintain constant velocity in the duct. Other systems can be designed for constant velocity or equal friction, which is basically constant pressure drop. Think about it. Systems with explosive or radioactive material should be balanced by duct sizing and not have balancing devices like dampers in the flow. Fire dampers are the smoke dampers are not even permitted in hazardous exhaust duct. Illustration 10J fixed minimum position blocking device. For other systems that are balanced with dampers, dampers are required to have fixed minimum position blocking device to prevent restricting the flow below the required volume for velocity. A damper clamp attached to a damper plate keep the damper from closing. Combustible dust exhaust ducts can carry combustible dust exhaust. When this happens, the code requires cleanouts with access for cleaning, or the duct must be engineered for automatic cleanout. Understanding the code, these cleanouts are required to be located at the base of each vertical duct riser and located at least every 20 feet within horizontal sections. Hazards exhaust duct concentration. International Mechanical Code 2021 Section 510.9 Hazards exhaust ducts have special construction requirements, and one of the following must be used. Study tip: hazardous exhaust duct construction options. G90 galvanized sheet steel with a minimum thickness as shown in the table 510.9. Non-metallic materials that are platinum rated for non-flammable corrosive fumes or vapor. An alternative material that is compatible with the exhaust if the first two options are incompatible. Construction and installation. The duct joints are required to have a minimum lap of 1 inch between sections. They can also use joints specified in ANSI SMAGNA Industrial Duct Construction Standard. Fast facts: the host hazard duct must be supported at least every 10 feet by non-combustible material. Clearance to combustible. Ducts required a clearance to combustible, but it is based on the temperature of the exhaust within the duct. Study tip: duct clearance requirements to combustible less than 100 degree Fahrenheit, 1 inch to combustible 100 to 600 degree Fahrenheit, 12 inches to combustibles greater than 600 degree Fahrenheit, exhausted to chimney, flammable vapor 6 inches. Understanding? Practice temperatures greater than 600 degrees Fahrenheit require in the use of chimney to exhaust to the outdoor. These temps are too great to rely standard exhaust ducting, duct stock and refuse conveying system. International Mechanical Code 2021, Section 511. When flammable ducts come into play, duct connections and exhaust system are required. Explosion control system are required for any potentially explosive mixture. Illustration 10K. Dust collectors. Dust collectors are separators should be constructed of non-combustible material and located on the exterior of the building. Minimum distances from other combustible material. Illustration 10L. This point of use collectors. Point of use and similar collectors can be installed indoors if they comply with International Fire Code and NFPA 70. Meter screens and safety relief vents. A meter screen is required to protect exhaust outlet from spark due to flammable dust in play. Safety relief vents are required for any system combined combustible that could explode. Illustration 10M. Safety relief vents. If a screen is installed in a safety relief vent, the screen needs to be installed to allow release under explosion pressure. Similar to above, outlets for exhaust that exceed 600 degree Fahrenheit are to be designed as a chimney per table 511.2. Did you know since 1785 over 200 people in the US have been killed in dust and bar explosions, which to some this may be not seem like an excessive amount of this. All of these are really unnecessary and preventable with today code regulation on handling dust. Sub-slab soil exhaust system, International Mechanical Code 2021, Section 512. In Module 7, we learned about plenums and the required rating for materials inside an air plenum. Now let's discuss Class 0 rated air ducts as they relate to make an flame spread rating installed underground or below grade. Understanding the code. Sub-slab soil exhaust system refer to exhaust duct running below grade, being in constant contact with soil and moisture. Code regulation govern the construction material used for underground ducts. Class 0 rated air ducts that are plenum rated with a flame spread index of 25 and smoke developed index of 50 are also known as Class 1 air duct. Class 0 air ducts have surface burning characteristics of 0, the lowest rating possible. Study tip: understanding the field. Only Class 0 ducts of IPC approved piping are allowed for subslab soil exhaust system, minimum 6 inch above roof and at least 10 feet from any opening or air intake. Slope must be 1% or 1 per 2 per 12. Illustration 10N subslab duct sloping and termination. Subslab exhaust duct must be sloped 1% or 1 per 8 12. Then the duct must extend through the roof, terminating at least 6 inches above the roof and at least 10 feet from any opening of air intake. Did you know the most common reasons to have subslab soil exhaust system are to control random or moisture? Negative pressure is created underneath the slab and will draw random and moisture from going through the slab into occupied space. Random gas forms naturally from decaying radioactive substance. It can be a big problem in varying location and no problem in other. It is a radioactive gas itself that has been shown to cause lung cancer. An effective under slab configuration. In order to be effective, sub-slab exhaust duct cannot be trapped. That is, there cannot be low spots in the duct that trap water. Fast facts: these ducts must be able to be identified from a tag or label as they pass through each level of building. Smoke control system, International Mechanical Code 2021, Section 513. Smoke control systems are intended to provide an environment during a fire or smoke event that allow occupants the ability to evacuate. Think about it, smoke control systems are not intended to preserve property, allow a quicker return to building operations, or help with the suppression. Type of smoke control system. The type of smoke control system described in the section are the systems specified by International Building Code or the International Fire Code, where a smoke control system is required and are designed per the International Building Code Section 909. A smoke control system can be passive or mechanical and can show compliance through pressurization, airflow, or exhaust method. We will look at each one of these compliance methods. Understanding practice. The International Building Code Section 909 required a special inspection and testing to verify proper commissioning for smoke exhaust system. Required analysis of Smoke Control System, International Mechanical Code 2021, Section 513.4. Smoke control systems are affected by other systems and the environmental around them. The code required an analysis of the smoke control system that considers specific effect. Let's look at these effects now. Remember that the smoke control system must be designed to prevent adverse interface from any of these effects. Possible effects of smoke control system to consider and resolve. A stack effect must not adversely interface with the system capabilities. Define terms. Stack effects is the same as chimney effects that we talked about when we covered chimney and vent. In tall building, a stack effect can use air to move like it does in chimney, pulling air up through lower floor and out top floor. 2. Buoyancy and expansion used by the design fire will not adversely interfere with its capabilities. Design fire is covered in the next section. Number 3. Wind effect must be considered. 4. The effect of the heating, ventilating, and air conditioning HVAC system on both smoke and fire transport must be considered, along with the effect of fire on the HVAC system. Number 5. The effect of low temperature on the system must be considered, along with effect on the property, the occupants, and the location of inlets and outlets to prevent snow or ice blockage. Number 6. The interaction effect of multiple smoke control systems operating for all design scenarios must be considered. Design fire, International Mechanical Code 2021, Section 513.9. Part of the analysis described above that is required from registered design professional in the design fire. Defining terms. The design fire represents the possible fire that could happen based on the analysis described above and the following consideration listed below. Study tip. Design fire consideration. Characteristics of the fuel load, effect of the fire, and whether the fire is likely to be steady or unsteady. Consideration of the type of fuel, fuel spacing and configuration. Fuel includes anything that can burn, furniture, framing, electronics, etc. that in the smoke control zone. The heat released from the fuel should be based on the best available data. Number 4. Any analysis for conditions that assume fire growth is halted at the time of sprinkler activation, taking into account when the sprinkler will activate and how that will affect the design fire. Smoke barrier construction, International Mechanical Code 2021, Section 513.5. Smoke barrier are constructed per International Building Code 709. The International Mechanical Code gives maximum leakage area ratios through those smoke barrier. Certain amount is expected to or permitted to leak, but not more. Understanding design, the leakage ratios don't include leakage in gaps around door and operable windows, only leakage through the actual barrier. To show compliance with the leakage areas, we must meet the minimum air pressure difference across the barrier when the smoke control system is running. For a passive smoke control system, pressurization must be shown through another approved method such as door fan testing. We can measure the air pressure difference by either the following. Study tip: measuring the air pressure difference. The system must be operating in the smoke control mode. For mechanical smoke control system, utilizing the pressurization method. Number 2, performing door fan testing. There are other similar methods for passive smoke control system. Automatic closing device. Illustration 10O. Automatic closing devices, smoke curtains. Opening and smoke barriers required automatic closing device actuated by mechanical smoke control system. This is so smoke can't spread. These devices can include door closure, make smoke curtains that drop from the ceiling, or smoke dampers in duct work. Illustration 10b, smoke dampers used in air transfer opening in smoke barrier. Ducts and air transfer openings through smoke barriers are required to be protected with a minimum Class 2 250 degree Fahrenheit smoke dampers complying with the International Building Code. Pressurization method, International Mechanical Code 2021, Section 513.6. There are three primary ways of showing compliance with smoke control requirements: the pressurization method, the airflow design method, the exhaust method. The pressurization method is the most common and does not require approval from the code official. Fast facts: to use the airflow design method or the exhaust method, code official approval is required. Illustration 10Q, pressurization, low pressure site and high pressure site, and this is the smoke. The primary mechanical means of controlling smoke is by pressure difference across smoke barrier. Sprinklered versus non-sprinkled pressure requirements. Remember that it is the pressure differences that ensure smoke will displace from one area to another, such as outdoor. For sprinkler building, the pressure difference across smoke barrier used to separate smoke zone should be at least 0.05-inch water gauge. Understanding the design in buildings that are not fully sprinklered. The smoke control system must achieve pressure difference at least 2 times the maximum calculated pressure difference produced by the designed fire. Without sprinkler system in place, the code places more stringent pressure difference requirements, ensuring smoke will move out of the area. Other compliance options. There are two options available to use in place of pressurization method: to use either the airflow design method or the exhaust method required the approval of the code officials. Note that both methods are detailed in NFPA 92. Airflow design method, International Mechanical Code 2021, section 513.7. The optional airflow design method uses openings between smoke control zone that direct airflow in order to limit smoke migration from the fire zone. Illustration 10R. The airflow design method. The airflow openings are arranged to prevent flow reversal from turbulent effect. The airflow method isn't allowed if it will cause problem to other parts of the smoke control system, intensify the fire, or interfere with existing. Also, the air velocity cannot exceed 200 feet per minute. The host method, International Mechanical Code 2021, section 513.8. The fire design height, plume, smoke layer, exhaust fan. Illustration 10 is the exhaust method. The exhaust method maintains the lowest height of the smoke layer at least 6 feet above any walking surfaces. Sorry, that is a part of the egress system with the smoke zone. Equipment. International Mechanical Code 2021, section 513.10. All equipment in smoke exhaust system will be subject to higher temperature than other systems. Therefore, smoke exhaust equipment must be rated for a higher temperature. The exhaust fan to use must be rated and certified from a probable temperature rise to which they may be exposed. The temperature rise is computed by Ts equal Qc divided by MC plus Ta, equation 5.3. Equation variable C, specific heat of smoke and smoke layer temperature, BTU per IP Fahrenheit. M, exhaust rate pounds per seconds. QC, convective heat output of fire, BTU per S. TA, ambient temperature Fahrenheit. TS, smoke temperature Fahrenheit. It can be reduced based on the assurance of adequate dilation air. Understanding the design. The locations of the inlet and the outlets should minimize the potential for introducing smoke or flame into the building, minimizing the exposure of additional additional people or property to smoke or flame. Illustration 10T, belt-driven fans. Belt-driven fans required at least 2 belts and need 1.5 times the numbers of belts required for the design duty. Fan motors cannot operate beyond this nameplate horsepower and required minimum service factor of 1.15. Defining terms. In simple terms, the service factor is the ratio of the gearbox rated horsepower or torque to the application's required horsepower or torque, applying to above code requirements. This means that the fan gearbox is required to be 15% more capable than the required horsepower for the task at hand. Standby power, International Mechanical Code 2021, Section 513.11. Simply take away from the section that the smoke control system required standby power served from the room that is separate from the room containing normal power. Detection and control system, International Mechanical Code 2021, Section 513.12. Illustration 10U, smoke control panel. Smoke exhaust control system interface with the building fire detection system. Smoke control panels are required for fire departments use the testing. Control air tubing, International Mechanical Code 2021, Section 513.13. Smoke control systems are often controlled by pneumatic actuators, especially doors that are automatically opened or closed. Pneumatic actuators require tubing that is pressurized with air from an air compressor. Type M, and this is type L, and this is type L. Illustration 10 V tubing for pneumatic actuator. The tubing need to be sized correctly, clean, protected from damage, and made of the L. Type L copper. The code also specifies the compression fittings are allowed at final connection to device, but otherwise the joints are required to be braced. Fast facts. Non-metallic tubing is allowed within control panels and at the final connection to device. If installed in galvanized or paint grade 22 steel enclosure and protected from damage. Energy recovery ventilation system, International Mechanical Code 2021, Section 514. This is the energy recovery system. The fresh air is come from outside, and here the fresh air going to whom? Okay, but here heat exchanger cooled, the exhaust air this is going from outside is hot, so there is exchange here to save the energy to make the fresh air come outside more hot and enter the building, and this is the exhaust air that we will throw outside the building. It will exchange the heat with the fresh air from outside, exhaust air to outside. Illustration 10W energy recovery ventilation system. Energy recovery ventilation systems are systems that transfer heat and sometimes moisture between exhaust air and ventilation air. These systems can save a lot of energy because the ventilation air gets pre-conditioned by the exhaust air before it goes through any mechanical heating or cooling and are sometimes required by the International Energy Conservation Code IECC in order to achieve a certain level of energy efficiency. The IECC provides detailed requirements for this system, yet there are no circumstances where energy recovery is not allowed. Let's take a look at this scenario as we close out our review and study of exhaust requirements. Study tip: where energy recovery is not allowed. Number one, hazardous exhaust system covered in section 510. Two, the dust, stock, and refuse system that convey explosive or flammable vapors, fumes, or dust. Number three, smoke control system covered in section 513. Commercial kitchen exhaust system serving type 1 or type 2 hot, closes dryer exhaust system covered in section 504. Air exchange mode, recirculating mode, illustration 10x recirculation, as long as the energy recovery system has less than 10% of the total airflow leaking from one side to the other, the air not considered to be recirculated, which is important to meeting code ventilation requirements. Let's review the quiz. Okay, the first one, which of the following does not require a maximum exhaust rate of 1 CFM per square feet? It is a 100 square foot vault containing tanks of gasoline. Question number two, cabinets holding compressed toxic gas requires a minimum velocity of ventilation at any point at the access ports to be not less than 150 feet per minute. If the equivalent length of dryer exhaust duct exceed 35 feet, the equivalent length shall be identified on a permanent label or tag within 6 feet of exhaust duct. Okay. Exhaust from laboratory that uses 50% hydrogen peroxide health hazard rating of 4 is removed in a duct and shaft. Which of these conditions would make it a requirement that no other duct can be in the same shaft? The exhaust system is served by one fan. Which of the following does not need to be taken into consideration in the analysis of for smoke control system? The effect of rain on the system. Okay, so we finish the module here for exhaust 2, this module number 10. The next one will be module number 11, this hydronic piping.